So this radius is 2. This radius is 2, and this height is root 3. So look at this angle. This is phi. So this angle will be pi by 2 minus phi, and sin pi by 2 minus phi is, I will write, so this angle is phi, this angle is phi, so the other angle is pi by 2 minus phi. So sin pi by 2 minus phi is opposite side, namely the height root 3 divided by hypotenuse. Hypotenuse is this, so it is 2 because the sphere is of radius 2, so root 3 by 2, but this is cos phi, left side, so cos phi equal to root 3 by 2 means phi equal to pi by 6. So for D1 the angle varies from 0 to pi by 6. To pi by 6, and theta, that is the shadow region. For the shadow region to sweep out, theta must vary from 0 to 2. So these are the limits of integration for the region D1. Now let us look at D2. So for D2, what happens is, first row variation. Row varies from where to where. So to determine that, draw a ray that starts at the origin and passes like this. So it enters the region when rho equal to 0. So the lower limit is 0. And what about the upper limit? So let us take a typical point. Let us say this point. So let the coordinates be x comma y comma z. X comma y comma z. So what about this height? It is precisely z. Now if this ray M makes an angle phi with the positive z axis, then the other angle, namely this angle, will be pi by 2 minus phi. Again, as we did earlier, sin pi by 2 minus phi is opposite side. It is now here z. By this distance. So what about that distance? It will be a square root of x square plus y square plus z square. But this point x comma y comma z lies on the cylinder. So x square plus y square is equal to 1. So the distance of this point is square root of 1 plus z square. 1 plus z square. So I will write here for D2. For D2, I will write to the other side of the board. So for D2, look at the point x comma y comma z. So what is the distance of that point from the origin? It is square root of 1 plus square root of x square plus y square plus z square, which is equal to, since the point x comma y comma z lies on the cylinder, x square plus y square is equal to 1. So it is square root of 1 plus z square so sine pi by 2 minus phi is equal to opposite side z divided by square root of 1 plus z square but then so we are taking sine. Okay, why don't we take tan? Better take tan instead of sine. So tan pi by 2 minus phi is what happened? Tan pi by 2 minus phi is equal to opposite side by adjacent side. Opposite side has length z divided by adjacent side. It is of length square root of x square plus y square plus 0 square. That means square root of x square plus y square, which is equal to 1. But this is cot phi what I want to find is this distance. So z is equal to cot phi. This distance is cot phi. This distance is cot phi. So what about this distance? Square root of 1 plus z square. So it is square root of 1 plus cot square phi. So this thing becomes equal to square root of 1 plus cot square phi so it is cosec phi. CSC. Yes, we found out the distance. So rho varies from where to where? Rho varies from 0 to cosec phi. So let us substitute for limit. For d2, this is cosec phi. CSC for cosec phi. Now what about the phi variation? It varies from pi by 6 to 0. No, pi by 6 to pi by 2, because the plane z equal to 0 is precisely phi equal to pi by 2. phi varies from pi by 6 to pi by 2. Hope you understand why it is pi by 6 to pi by 2, because to describe d2 we need m to vary from here to here. When here phi is pi by 6 and when here it is phi equal to pi by 2. And finally theta, that is the shadow region. It is completely swept out when theta varies from 0 to 2 pi. And therefore we can substitute. So triple integral over d1 dv is equal to integral theta varies from 0 to 2 pi, integral phi varies from 0 to pi by 6, integral rho varies from 0 to 2, rho square sine phi d rho d phi d theta plus, substitute for this thing. So what I will get? Integral theta varies from 0 to 2 pi, integral phi varies from pi by 6 to pi by 2, and integral rho varies from 0 to cosec phi rho square sine phi d rho d phi d theta. That will be this. And you are not asked to integrate. You have to just set up for limits of integration. So we have completed on part A, and part B is left as homework. Thank you.